You know, in our digital world, the guardians protecting our most critical stuff, they're not in watchtowers anymore. They're in the cloud. We're talking about cloud security engineers, the folks on the absolute front lines. And today, we're going to decode the blueprint for becoming one, the Google Cloud Professional Cloud Security Engineer certification. Let's dive right in. So what does it really mean to be a cloud security engineer, especially in the Google Cloud world? Look, it's so much more than just firewalls and passwords. Think of yourself as an architect. You're the one designing, building, and managing the entire security setup for a cloud solution, using all of Google's powerful security tools. So yeah, this exam, it's not just a test. It's proof that you've truly mastered this super critical role. Okay, to master the role, you've got to master the domains. The whole exam is basically broken down into these 5 core pillars. And just look at the weights here. They're pretty significant across the board. I mean, configuring access and data protection together, that's almost half the exam right there. This chart is basically our roadmap for this whole explainer. It's Google telling us, hey, this is what you really need to know. All right, here's our game plan. We'll start with what it means to be a modern cloud guardian. Then we're going to jump into 4 key scenarios pulled straight from practice questions that hit those big domains we just saw: access, network security, data protection, and ops. And to wrap it all up, we'll talk about how you can figure out if you're ready to take on this exam yourself. So let's start with the biggest piece of the pie: configuring access. This is all about a core concept you'll hear again and again, the principle of least privilege. It's simple, really. You give people and services only the access they absolutely need, and only for as long as they need it. No more, no less. Honestly, it's the bedrock of all good cloud security. Now, pay close attention to this requirement. The interesting part isn't just what access the team needs, it's when. See that phrase, only during the deployment issue? That's the key. This idea of temporary, time-bound access, well, that's a classic real-world security headache they want you to know how to solve. Okay, so here's the situation. Something's gone wrong, an incident is live, and your DevOps team needs to jump in and figure it out. But you can't just hand over the keys to the kingdom forever, right? So how do you solve this puzzle? How do you give them the access they need right now without breaking security best practices? And this is where we see the 2 paths you could take. The flawed logic, giving the team a permanent, always-on role. That's a huge standing risk, just waiting for something bad to happen. The correct logic is what we call just-in-time access. Here's how it works. You create this sort of temporary, robotic identity, a service account, with super limited permissions. Then the DevOps team can essentially borrow that identity's permissions, but only when they need to. As soon as the incident's over, poof, that access is gone. It's clean, it's temporary, you can track it, and it's way more secure. All right, let's keep building on that. We've talked about controlling who gets in. Now we're shifting to controlling where your data and services can even go. This is all about building digital fortresses. And I'm not just talking about your servers. I'm talking about managed services, the ones that by default kind of live out on the public internet. Now, this requirement sounds simple on the surface, right? But in the cloud, this is actually a really big deal. See, a service like cloud storage is global. Its front door, its API is on the public internet. So the million-dollar question is, how do you take a public service and basically wrap it in a private bubble just for your organization? So let's paint the picture. You've got a bucket full of super sensitive data. You need to lock it down so it can only be accessed from inside your trusted network. But, and this is the important part, you also have to stop someone, or even just an accident, from copying that data out to some random bucket on the internet. This is the classic nightmare scenario: data exfiltration. And this is all about using the right tool for the job. On one hand, you've got something like VPC peering. Think of that as building a highway between 2 cities. Sure, they're connected, but it does absolutely nothing to stop someone from walking out of a bank with a bag of cash. The correct approach is VPC service controls. This is like putting a giant, secure fence around the bank itself. It creates this virtual perimeter right around the service, and it physically stops data from leaving that boundary. Big difference. Okay, next up, let's talk about one of the most important domains: data protection. And when we say protecting data at rest, we're really talking about 2 things: encryption, and maybe even more importantly, who holds the keys to that encryption. All right, let's quickly run through our options. First up is CSK, which stands for Customer Supplied Encryption Keys. With this one, you are in total control. You hold the key, and you have to provide it every single time you read or write data. Google uses it for a split second and then immediately forgets it ever saw it. It's maximum control, but also maximum responsibility. Then we've got CMEK, Customer Managed Encryption Keys. Now, this is often the sweet spot for a lot of people. It's a great balance of control and convenience. The key lives inside Google's own key management service, or KMS. You still control its whole life cycle. You can create it, rotate it, destroy it, but you get to lean on Google's awesome, secure infrastructure to manage it.
And finally, there's Cloud EKM, the External Key Manager. This is for when you have a super strict rule, usually for compliance, that says your keys absolutely cannot be stored in the same cloud as your data. With EKM, your key lives in your own system, completely outside of Google. When Google needs to encrypt or decrypt something, it has to make a call out to your key manager to get permission. Okay, so we've got our 3 options defined. Now for the pop quiz. Here's the scenario. A client tells you, my encryption keys cannot, under any circumstances, be stored in the same cloud as my data. This is a really common requirement in finance or healthcare. So, based on what we just learned, which options work?
And the 2 correct answers are CSEK and Cloud EKM. So why those 2? It's simple. In both of those setups, the actual key material is never stored by Google. With CSEK, you're holding it. With EKM, your own external system is holding it. CMEK, as great as it is the wrong choice here because the key is stored in Google's KMS, which breaks that not in the same cloud rule. This is a perfect example of how you have to map a business rule directly to the right tech.
All right, for our last technical scenario, we're diving into security operations. And here's the thing about the cloud. If your security is manual, it just doesn't scale. It's impossible. The goal here is to automate everything you can, to turn those tedious, error-prone tasks into rock-solid automated workflows that you can actually trust.
So check out this requirement. You've got to patch all your VMs with critical updates, not just once, but every single day. And you have to provide reports to prove you did it. Now imagine trying to do that by hand across hundreds or thousands of VMs. It's just a recipe for disaster. You'd go crazy. You need a system for this. And of course, Google Cloud has that system. It's called VM Manager. And the solution is actually beautiful in its simplicity. Step 1, make sure the VM Manager agent is running everywhere. Step 2, from one central place, you set up a recurring patch job. You just tell it, hey, every day, go find all the critical updates and install them. That's it. And this is why automation is king. This approach gives you that single pane of glass for everything: scheduling, running the patches, and, so importantly, getting those compliance reports. It means no more manually logging into servers, no more trying to maintain a bunch of fragile scripts. That old way is not just a nightmare to manage, it's also super insecure. So there you have it. We've walked through some real-world scenarios covering access, networking, data, and operations. You've gotten a taste of the kind of thinking this exam is testing. So the big question now is, how do you know when you're ready to take it on? Well, the source material for this explainer has a fantastic tool that can help. It's a simple readiness scorecard. And the idea is powerful. Just go down the list of the big domains we talked about and be honest with yourself. Rate your confidence on a scale of 1 to 5. Look, this isn't about getting a perfect score. It's about finding those areas where you're a little shaky so you know exactly where to focus your study time. And we'll end on this final thought. Learning all this stuff is great, but what really matters is putting it into practice. So I want you to think about it. What's the one security principle from today that you can apply tomorrow? Maybe it's reviewing an overly permissive role, or thinking about a service perimeter, or automating one little manual task. Whatever it is, that's the moment you stop just studying for an exam and start really thinking like a cloud security engineer.